Okay, so the part of St Andrews' involvement in this stage is all about the remote sensing, and as a geophysicist and not a biologist in here, that's my kind of field of expertise really. So we're looking at remote sensing technologies that can be used not just by the fishermen themselves, but obviously by management to see what is in these fisheries, and we're focused particularly on the scallop issue that Mark brought up earlier. So it's all about initially a desk-based assessment of the technologies that are being used currently, and of course we've got a whole range of, if you want, sophistication in technologies, everything from the simple echo sounder that is on almost every vessel, going from that and what people do with echo sounders, not just looking at the bottom of the seafloor, but looking at the textural response of the seafloor and trying to interpret that in terms of what is actually on the seafloor or buried or digging and burrowing into the seafloor. From that, all the way up through multi-beam sonars, which are becoming more and more common on more and more vessels, and going all the way through to what are the sort of top-end scientific instruments. And when you look at that range of different technologies, what you find is that we've not cracked yet in either the scientific end of things or in a practical use sense, we've not cracked getting an instrument that actually truly can tell us what is on the seafloor. And a lot of our interpretation of what is on the seafloor actually comes from more, if you want, gut feeling of I've been over these seabeds, I know what is here, and I've come to recognise the signatures of what's on the seafloor, rather than a hard scientific quantification of what's on the seafloor. So the whole objective here is to assess technologies that can be used to give a rigorous quantification of different elements, and in this particular work package it's about the scallops and scallop grounds. So we've undertaken a desk-based review of what is state-of-the-art today of what's on the seafloor, and we're going to be moving in a few weeks' time into a limited set of sea trials, and then we're going to be evaluating those sea trials in terms of the respect to industry capacity and cost effectiveness for actually taking these technologies and using them effectively. Who we are, it's not just St Andrews. I'm there in St Andrews. Actually, I come from the, if you want, the earth sciencey background, and that fits in because we're looking at a seafloor in terms of the habitat that it is, and that's based on the types of sediments or rock that is down there. But we have statisticians in St Andrews that are playing into this project, and then we have collaborators over on the west coast in SAMS, particularly in John Howe's group over there, and we actually have a very unusual, often or counted unusual contribution here from a company that has spun out of the oil and gas industry. And as we are trying to take the state of the art, we have actually looked very broadly to what that might mean, and actually some of the state of the art is coming from the oil and gas industry and miniaturizing some of their technologies to try and apply in this sort of high resolution field. So we've gone through this desk-based review, we're moving into sea trials. Of course, this is remote sensing, and it is only as good as the ground truth. And of course, obviously, the ground truth comes from actually getting data back from the seafloor, and that's of course through ultimately the scallop dredging and the scallop hand diving operations, that is the fisheries, but it's also through the scientific diving that goes on some of these sites. And we'll be using scientific divers and well-established methodologies to provide the ground truth for what is actually down there, and we'll be able to compare that then back to what our remote sensing techniques are telling us we think is down there. So at the end of the day, we hope to compare these two sets of data and come up with recommendations of a range of technologies. We hope that there will be a range of technologies that can be used under different circumstances, and by that I mean probably different vessels and types of operation, to be able to use both from a fishing point of view of assessing what is down there, what's the resource that's down there, but of course at the other end of the scale, at the, if you want, the monitoring, the management point of view of what's down there. Test sites, We're going to the west coast to do some of these test sites, and that's our decisions here have been mainly based on previous knowledge of good scallop areas and varied areas that we can go to within a relatively cost-effective mobilisation of resources. So here around the Firth of Lorne, we've got 3 sites highlighted so far, and we're trying to hit sites with different ground conditions. So ground conditions being, different water depths, different velocities of water, different ranges of exposure, different types of material on the seafloor in terms of sediment types in there. And so that's just highlighting some of those. So they're known sites that particularly SAMS has worked on with local divers over the years. Types of technology. I mentioned single beam echo sounders. That's the simplest end of the scale in there. Many fishermen have used for many years augmentations to that in the terms of things like QTC, Roxanne, ways of classifying that simple echo from the seafloor. Many of them are now moving into the multi-beam sonars, so looking at swathes of seafloor. We're going to go one step further, and what we actually have available to us today are called multi-frequency multi-beam sonars, and we're doing that because we think by using multi-frequencies we might actually not only get character discrimination on the seafloor, but we might also start to get small amounts of penetration into sediments, and for scallops that could be very important in terms of how scallops live on that seafloor. We're going to be using bathymetric side scan sonars, and these are more industry standard for side scan sonar and can be deployed on lots of vessels of opportunity. So in a monitoring sense in the future, we don't want to be looking at just technologies that can only go on very bespoke high-end research vessels, because that could be cost prohibitive for long-term monitoring. And we're also going to be looking at remote sensing using AUV, so autonomous underwater vehicles. This is the way the survey industry is going, and although it represents a very expensive end member of surveying, as costs inevitably come down as more of these things are deployed, they might have benefit for this type of work. Traditional sampling for ground truth, video, diver, still, drop-down cameras and things. So just an example, we're not going to go out and sea kayaks, but the upturned sea kayak, in fact, there has one of the sonars on it. We don't want to operate it in water, in the air like that, but when it's the other way up. It's a multi-frequency, multi-beam sonar, very easily deployed piece of equipment that could go on many vessels of opportunity. This represents the latest in multi-beam technologies, and actually they are very as I say, easy to deploy, low footprint in terms of how you might put them on a survey vessel. We'll be testing these sorts of things out, looking at a whole range of frequencies on the seafloor. We'll also be using this out of SAMS. This is an AUV. This is an autonomous underwater vehicle. It's the Gavier offshore surveyor. This isn't the sort of thing that everybody's going to have and go out there with. Very expensive piece of equipment, or toy, as they like to really refer to it. But it's incredibly sophisticated. You can take different packages of sonar technologies onto it, and this might represent, if you want, the management side of input to what could be done in monitoring some of these areas. So, range of techniques, we're going to go out, apply them to a range of sites, and we hope we will be successful in getting a range of results that will be applicable to different end members of this spectrum that is needed to assess what's on the seafloor. Thank you.